What if time isn't real? What if it's just a construct of our minds, a way for us to organize our perceptions of a universe where past, present, and future all exist at once? And what if black holes, those cosmic chasms of unimaginable gravity, aren't endpoints at all but gateways to other universes, other realities? We like to think we have a handle on this cosmos we inhabit, that our understanding of physics and the laws of nature is secure, but what if I told you that some of the most brilliant minds in science are exploring theories that suggest our reality is far stranger, far more wondrous, and far more terrifying than we ever imagined? Theories that hint at a universe where the very fabric of existence is in question, where our place within it is more precarious, more awe-inspiring than we ever dared to dream. Get ready to have your mind blown wide open, because we're about to embark on a journey through 10 scientific theories so profound, so paradigm-shifting, they'll change the way you look at everything. Imagine a reality where every decision you've ever made, every path you didn't take, exists in a parallel world. A reality where another you is living out the consequences of those choices, for better or for worse. The many worlds. Interpretation of quantum mechanics suggests that every time a quantum measurement is made, the universe splits. It's not just that a particle takes one path or another, it takes all of them, but in different diverging universes. Right now, there could be countless versions of you out there, each a product of a different set of choices. In one universe, you might be a celebrated astrophysicist, while in another, you're a struggling artist. Some physicists believe that evidence for these parallel universes might be detectable in the faint echoes of the cosmic microwave background radiation, the afterglow of the Big Bang. These echoes could be the fingerprints of other universes brushing up against our own. It challenges our very notions of identity, of free will, of destiny. So, the next time you find yourself pondering the road not taken, take comfort in the possibility that another you might be living out that very choice in a parallel universe not so far away. We experience time as a linear progression, an unstoppable march from the past, through the present, and into the future. But what if this perception of time is nothing more than a stubborn illusion, a trick of our human consciousness? What if, in reality, the past, present, and future all exist simultaneously? Einstein's theory of relativity shattered our classical understanding of time, demonstrating that it's not absolute but relative to the observer's frame of reference. Time, according to Einstein, is like a river, flowing at different speeds depending on the gravitational field. Some physicists believe that if we could step outside the confines of our four-dimensional spacetime, we'd see time not as a river, but as a vast, unchanging ocean. Every moment, from the Big Bang to the end of the universe, would exist eternally, frozen in this cosmic snapshot of existence. If the future is already written, do we truly have free will? Or are our choices predetermined, playing out like a script on the stage of this preordained universe? The next time you glance at a clock, remember that the ticking hand might be measuring nothing more than our limited human experience, a convenient fiction in a universe where time itself might not exist at all. What if everything you see, touch, and feel isn't real? What if our universe is a sophisticated computer simulation? The simulation hypothesis is gaining traction among some physicists and philosophers. Imagine a civilization far more advanced than our own, creating such simulations. How would we even know if we were living in a digital world? Are we just lines of code in a cosmic computer program? Black holes, those enigmatic cosmic monsters, have long captivated our imaginations. They are regions of space-time where gravity is so strong that nothing, not even light, can escape their clutches. But what happens when something falls into a black hole? Where does it go? Recent theories suggest a far stranger, far more mind-bending possibility. Black holes might be gateways to other universes. Imagine the fabric of space-time as a vast sheet. A black hole, with its immense gravity, would warp this sheet, creating a deep well that plunges down into the unknown. Now imagine that at the bottom of this well, instead of a singularity, there's a tunnel, a wormhole, connecting our universe to another. Some physicists believe that these wormholes, also known as Einstein-Rosen bridges, could be created by the extreme gravitational forces at play within a black hole. These tunnels could be shortcuts through space-time, allowing matter and information to travel vast distances, perhaps even to other universes. Black holes, once thought to be cosmic dead ends, might be the key to unlocking the secrets of the multiverse. We like to think we have a pretty good grasp on what our universe is made of. After all, we can see the stars, the planets, the galaxies swirling through the cosmos. But what if I told you that everything we can see, everything we know to exist, makes up a paltry 5% of the universe? The rest, a staggering 95%, is shrouded in mystery, a cosmic enigma known as dark matter and dark energy. Let's start with dark matter. It's invisible to our telescopes, undetectable by any instrument we've devised, yet we know it's out there, lurking in the shadows, holding the universe together. How do we know? Because of its gravitational influence. Galaxies are spinning far too fast for the amount of visible matter they contain. Stars dance around their galactic centers with a velocity that defies the laws of physics. Unless, of course, there's something else out there, something massive, something invisible, providing the gravitational glue to keep everything from flying apart. That something is dark matter. The mystery of dark matter is a stark reminder of how much we don't know about the universe we inhabit. The Big Bang. The grand event that birthed our universe, a cosmic explosion from a point of unimaginable density and temperature. But what if the Big Bang wasn't a singular event? What if it was just one chapter in an endless cycle of cosmic creation and destruction? The idea of a cyclic universe, a cosmos that expands and contracts, dies and is reborn, has been around for centuries. But recent cosmological models have given this ancient idea a new lease on life. One such model is the ekpyrotic universe, which proposes that our universe is just one of many three-dimensional brains floating in a higher dimensional space. These brains collide periodically, and these collisions trigger Big Bang-like events, creating new universes in the process. Another model, known as the conformal cyclic cosmology, suggests that our universe will eventually expand to a point where it resembles the state it was in just before the Big Bang. At this point, the universe undergoes a kind of cosmic reset, a new Big Bang occurs, and the cycle begins anew. The implications of a cyclic universe are profound. The world of quantum mechanics is full of strange and counterintuitive phenomena that defy our everyday understanding of reality. And perhaps the most bizarre of them all is quantum entanglement, a phenomenon that even Einstein called spooky action at a distance. Imagine two particles linked together in such a way that they share the same fate no matter how far apart they are. You measure the state of one particle and instantly you know the state of the other, even if it's light years away. It's as if these particles are communicating with each other instantaneously, violating the cosmic speed limit of light. In the quantum realm, particles exist in a superposition of states, meaning they can be in multiple states at once until they are measured. When you measure the state of one entangled particle, you force it to choose a state, and this choice instantly determines the state of its entangled partner, no matter how far away it is. The implications of quantum entanglement are profound. For one, it challenges our understanding of locality, the idea that objects can only be influenced by their immediate surroundings. Quantum entanglement is a mind-bending phenomenon that challenges our very notions of reality. What if everything you see, everything you touch, everything you feel, isn't real? What if our three-dimensional world is just a projection of information stored on a distant two-dimensional surface, like a cosmic hologram? It sounds like something out of a science fiction novel, but the holographic principle is a serious idea being explored by physicists at the forefront of theoretical physics. It's based on the mind-bending idea that the information content of a region of space is proportional to its surface area, not its volume. Think of a hologram. It's a two-dimensional object that can project a three-dimensional image. Similarly, the holographic principle suggests that our three-dimensional universe might be a projection of information encoded on a distant two-dimensional surface, perhaps at the edge of the observable universe. The holographic principle is still highly speculative, but it has some intriguing implications. If our universe is just a holographic projection, then what is real? Is there a deeper level of reality beyond the hologram? The universe is vast, ancient, and teeming with billions upon billions of stars and planets. So with all that cosmic real estate out there, where is everybody? This is the Fermi paradox, named after physicist Enrico Fermi, who famously posed this question during a lunchtime conversation with colleagues. The paradox lies in the apparent contradiction between the high probability of extraterrestrial life existing and the lack of any evidence for it. The universe is billions of years old, which means there's been plenty of time for intelligent life to evolve on other planets. And given the sheer number of stars and planets out there, it seems statistically improbable that we're alone in the cosmos. So, where are all the aliens? Why haven't we detected any signs of their existence, such as radio signals, spacecraft, or even megastructures built around stars? There are numerous proposed solutions to the Fermi paradox, each more mind-boggling than the last. Some suggest that intelligent life is incredibly rare, and we're one of the first civilizations to emerge in the Milky Way. Others propose that advanced civilizations might be deliberately hiding from us, perhaps to avoid being detected by hostile aliens or to prevent us from interfering with their development. Another possibility is that advanced civilizations tend to destroy themselves through war, environmental destruction, or other self-inflicted calamities. The Fermi paradox is a humbling reminder of our own cosmic insignificance. We've journeyed through the cosmos, explored mind-bending theories, and confronted profound mysteries. Now we arrive at the final theory, the one that ties it all together. A theory so audacious it suggests our universe is just one bubble in a cosmic sea. Imagine a multiverse teeming with infinite bubble universes, each unique, some similar to ours, others incomprehensibly alien. The implications are staggering. So, there you have it. 10 scientific theories that challenge our perceptions of reality and hint at a universe far stranger and more wondrous than we ever imagined. Which of these theories shocked you the most? Do you think time is an illusion? Or are we living in a simulation? Let me know in the comments. And while you're pondering the nature of reality, be sure to subscribe to this channel for more mind-blowing explorations of the cosmos. In our next episode, we'll delve into the mysteries of the human brain and explore the possibility that we have untapped psychic abilities. Until then, keep questioning, keep exploring, and never stop looking up at the stars.